Hello again. So in the last video we got the webcam up and running, and in this video we're going to actually get into the meat of it, which is the pose estimation with TensorFlow.js. So if you haven't seen the first video yet, you can go back and check that. That will be linked in the description. But if not, if you have seen it, let's get going with the pose detection. So before we get into it, in case you don't know, let me just show you TensorFlow, the TensorFlow.js website. So TensorFlow.js basically allows you to run these machine learning models, but directly in the browser, which I think is amazing because as a front-end developer, you might kind of think that machine learning and AI is a bit out of reach. You need to be this crazy machine learning developer who knows lots of back-end code and Python and is a big data wrangler. But really, TensorFlow.js makes it like incredibly accessible because they've built all of these pre-made models that you can just import and use, and you know they do all sorts of things from speech recognition to face detection. But in our case, we're interested in this pose detection one here. So you get through to this little repository, and then on here you'll see that there's like 3 models to choose from. They've all got pros and cons, but in our case we're going to use Blaze Pose, and the reason I chose Blaze Pose was just because in testing it seemed to be one of the most accurate, and it's got a few more key points than some of the other ones. So the way these work is they analyze your webcam feed, and then it tries to detect a body, or in our case a skeleton in the feed, and then it gives you back a list of key points. So key points are things like your elbow, your wrist, your eyes, your nose, and then it can sort of like join up between them as well and keep track of them. So yeah, we're using Blaze Pose. These other ones work well as well, so I guess just try them out for your specific project. Okay, so let's get going then with that. So the first thing we need to do is install a few new dependencies. So I just open a new terminal here, and then so we just need to install some dependencies here. So let's get those in. So we're going to want to install the pose detection models themselves and the TensorFlow WebGL backend. So let's do that now. So you can choose different backends with TensorFlow.js, which I find a bit of a confusing terminology considering TensorFlow.js is run on the front end, but you can choose to use the WebGL backend, which runs it on the graphics card, so that's really fast, or you could also do it on the CPU, which is a lot slower, and I think they also have WebAssembly. I think the WebGL one's the sort of most widely supported, so that's why we're going with that. Okay, so they're installed now. So the next thing is to import those into our main TS file. So let's do that now. Import star as pose detection from. That's the one. And then we also need to import the backend like this. Cool. So now that we've got that, we're going to create a new function down here, and it's going to initialize all the pose detection. So it's going to be another async function, a init pose detection. And the first thing we're going to do is create a const that's going to hold the model that we're using. So the model we're using, as I mentioned, is Blaze Pose. So we can get that like this. And then the next thing we're going to do is create a detector. And the detector is the thing that is actually going to be detecting these poses for us. Pose detection dot create detector. And then you pass it the model, so the Blaze Pose model, and then we also pass it this config object. And in here we're going to specify the runtime of TensorFlow.js. You might have noticed that there's another one called MediaPipe. Now, in my testing, MediaPipe had insane performance on my laptop, but terrible performance on my iPhone, which is annoying. So I found that the TensorFlow.js runtime is just a lot more consistent. It has worse performance, but it works better on more devices, it seems to me. I might be wrong about that, but you have a little test yourself. The next thing is the model type. So there's a few options in here. We're going to go for light. They basically sort of specify what version of the Blaze Pose model you want to use, with light being the quickest and least resource intensive to run, but also the least accurate. I think either heavy or full. I'm not sure which one's the biggest, but one of these is the most accurate, but is also the most resource intensive and has the biggest download. But for our purpose, we're going for light. We found that even light is super accurate and works really well. And then we're also going to do max poses 1. That just tells it that we only want to find one pose at a time. Again, makes it run a bit quicker. And finally, just to stop TypeScript complaining there, we're just going to cast this to this one. That one. Yes. And then at the end of this function, we'll just return the detector so that we can use it. Cool. So now we've got this. We're going to go down into our start function and we're going to actually get our pose detector. Like that. And then to use it, we're going to create a new function in here. And we're going to call it render. So this is going to be run on every animation frame, if possible. And then we're going to call the pose detection in here to get our poses. So detector, estimate poses, and then all you have to do is super easy. You just pass it the video element, and then that does all the magic. Which is really, really cool. You know, for something as complicated as this, you'd think it might require a bit more setup, but it doesn't. So for the time being, let's just log those out to see what we're getting. Poses, and we want to make this function call itself on request animation frame, so it keeps going, starts a render loop, and then finally down here, we'll just kick it off like that. Okay, so if I save that now, get rid of that. Open the inspector here. We've got my video feedback. Now the first time that this runs, it takes quite a while to do the initial poses. And especially as I'm screen recording and things, it's probably going to take even longer. But hopefully in a minute we should see a little array coming out here with poses. So there we go, right on cue. Now if I open that out, you'll see it's array, and it's only got one item because we've told it to detect max poses of 1. If there were more poses and you had a bigger value for that, you'd get multiple ones in here. And then if we open these out, you'll see that they're an object made up of a few properties, but the one we're interested in is this key points one, and it's basically just sort of the vector locations of these key points. So there you go, I've opened up the nose one. So you've got the name, the score, which is how confident it is that it knows where that key point is, and then you've got its X, Y, and Z coordinates. For this demo, we're only really going to care in the X, Y, and Z, so we can sort of position things horizontally and vertically where they need to go. So that's working now, which is great. So we're doing a load of clever AI there, and as a developer, all you've had to do is this tiny bit of setup and then call this estimate poses function, which I think is just really, really awesome. So the next step, now we've done the pose estimation. I'm just going to stop this from running for a sec because it's quite resource intensive. and it's going to make my laptop take off. So we've done the pose estimation. The next step is just to sort of validate that this is working and that it actually is figuring out where these key points are. We're going to do a very, very simple version of drawing the skeleton, and actually we're just going to draw some dots on my eyes, a dot where my nose is, and then a line where my mouth is, just so we can check it's working. Oh, just before we move on, I'll quickly just show you an image of the key points so you can get an idea of what we're working with. So this is what you should be returned. This is like the sort of key that shows you all the points that it can figure out. You can see it's quite detailed. You even get like these in the hand. You get like a thumb and a few fingers, so you can like twist the hand and things like that. It's really clever. Okay, anyway, so drawing the detected pose. What we're going to do here is we're going to create a new file called skeleton.ts, and this is going to export a class, and this class is going to be responsible for drawing our skeleton on each render. So we're going to add a constructor, and in the constructor we're going to pass in the canvas rendering context, so that the skeleton's going to be able to use that to actually draw things onto the canvas. And then we're going to create a private function called drawHead, and this function is going to be passed in a pose. The pose being that array that we were looking at. Oh, I've closed it now. With the key that has the key points in it. So then when we've got that, what we're going to do up here is we're going to get references to the key points that make up the head. So as I mentioned, we're going to draw dots in the eyes, so we need to get the eyes. And we can just do a simple find to do that. We're going to do the same for the right eye. And then we're going to want to do the same. Ooh, what have I done there? Oh, did it again. We're going to want to do the same for the left mouth and right mouth. So let's correct that. So annoyingly, I don't know why they've done this, but I mean, it's not a big complaint considering how amazing the library is, really, but it's not consistent. And instead of being right mouth, left mouth, it's mouth, left, and mouth, right. Seems to be the only one that's like that, which is strange. And then finally, the last one we're going to get is a reference to the nose. So, nose. Cool. So, as I said, this is just the hello world. We're just going to use the basic canvas API to draw some dots and lines where these bits and pieces are. So let's start by setting the fill style on the canvas to red, just so we can see it clearly. Let's set the stroke style to red as well. And let's set the line width to 5 pixels, should do nicely. And then let's go about drawing each one of these bits. So if we've got the left eye, it's important to do an if, because you might not always have it if it hasn't like detected it in the pose. So you don't want to try and draw it if it's not there, get errors. So we're going to begin a path, and then we're going to use the canvas arc function to draw a circle. Oops, left eye. So then here we're going to use the x coordinate on the left eye key point. We're going to do -10. I'll come back to why we're doing that in a sec. And then we're going to do the y coordinate -10, and then we set the radius of the arc, so that's going to be 10. And now this is why we're doing the -10 here, because we want to draw the eye on over the center of the point rather than the top left. So because the radius is 10, it means in total the circle is going to be 20 pixels wide. So this just shifts it back 50% so that it's going to be over the centered over these coordinates. And then we have to do the start angle of 0, and then we want to draw a full circle, so we have to do 2 times math.pi. And then we can just do this context.fill to actually fill in that circle. So let's leave it there for a second, and we'll just test this left eye's drawing. So before we can do that, we're going to want to create a public function called draw, and that's going to get the pose, and then like that, and then it's going to do this dot draw head and pass it the pose. So you might have guessed, but eventually we're going to have like lots of these draw functions in here for each of the other body parts, but for the moment we've just got one. So to go test if that's working, we'll go back to our main TS file, and in our start function, let us create a new skeleton. We'll get that imported, and then we have to pass it in the context. Could have actually done this up here, but we'll leave it down there for the moment. Yeah, we passed in the canvas context, and then if we go into our render function, we get the poses in there, and then what we're going to do is we're going to clear the canvas on each render so that we start with a fresh starting point. And then if we have poses 0, so again there might not be any poses if there's no one in the frame, so we need to have a little check there. We want to do skeleton.draw poses 0. Let's stop logging those out now as well. Okay, so if we save that, let's just get up inspector to make sure there's no errors. We should hopefully see in a sec that once it starts to detect the poses, we should see a little dot on my left eye. Fingers crossed. Oh, I'm an idiot. Classic dev moment there. Look, I got rid of the render function here. So this never started. Let's go. It's going to work this time. Aha! There we go. You can see the dot on my eye, which is cool. It's a bit laggy because I'm doing screen recordings and stuff as well, but there you go, it's stuck to my eye. I move up and down, it's following it around. So there we go, that's kind of showing that it's working. So what we'll do now is we will just fill in the rest of the face so you can kind of get a sense for it. Let me just copy this from somewhere where I did it earlier to save you the pain of me typing it all out. But we're going to do basically the same thing again for each piece. The only difference being the mouth, instead of doing a circle, we're going to draw a path between those 2 points. So you do that with the move to and then line to and then stroke methods on the Canvas API. So let's update that. Sorry if you can hear my fans going now, but it does get quite resource intensive. you end up spending a lot of time looking at yourself when you're working on this sort of thing. Aha! There we go. So you can see my mouth now as well. You can turn your head and it follows it around. So it's kind of proving the pose detection is working. Obviously we're drawing the head, but our other lip, we can sort of hopefully guarantee that our other limbs will be working in a similar way. Cool. So let's just stop my computer taking off again. Great. So we've done the first 4 steps now. We've got 1 step left, and that is to actually map the skeleton to the pose. I think we'll do that in another video now. We've spent quite a while on this one, so I hope to see you in the next video. Obviously subscribe to be notified when that's coming out, and we'll see you then to do the final part of skeletonizing yourself with pose detection. See you then.